Hello, Mario! In this video, triangles every which way. We'll be looking at triangles in all sorts of directions. But before we start, let's have a little look at this gem from an exam paper. The old classic, Find X. Well, here you go, here it is here. Wasn't that hard after all, was it? Okay, moving on. Question. But first, let's get rid of that title page. In a triangle, you use a theodolite and tape to measure the following. The angle BAC. Well, that was triangle ABC, of course. The angle BAC you measure is 56 degrees, 45 minutes and 00 seconds. From A, you measure a slope distance of 126.37. Slope distance, just be careful about that, with a corresponding zenith angle of 95 degrees 30 minutes to B. You then measure a slope distance of 127.39 with a corresponding zenith angle of 82 degrees 35 to C. What is the horizontal distance between B and C? Well, that's certainly a pretty wordy question. Pretty wordy indeed, alright. So let's try and make some sense of that by first drawing a diagram. Good place to start would be with, of course, triangle ABC. And then we put in the information that we know in green. So from A to B, now just remember this is a slope distance and it's at 95 degrees 30. That's a zenith angle, or zenith distance sometimes referred to. And then we've got in there our little 56 degrees 45 there, and then our other slope distance AC. So clearly the first thing we have to do is to reduce these slope distances to the horizontal. And how do we do that? Well, first of all, we need to look at the old zenith angle. Now, these three green sticks are traditionally what I use to indicate a measuring instrument, total station with theodolite. And the zenith angle is measured from the point above the mark, the zenith being above the mark, and if you're really interested, the nadir, N-A-D-I-R, is the point below the mark, or way down. So the zenith angle is measured from the zenith. So a zenith angle of, say, 95 degrees 30 is actually an angle of depression. It's 5 degrees 30 below the horizontal, as I've shown here. Sometimes the 5 degrees 30 is sometimes called a vertical angle. In this case here, which I haven't shown it, but it would be negative 5 degrees 30 because it's an angle of depression. Obviously, angles of elevation, which are above the horizontal, would be less than 90 degrees. So a 5 degrees 30 angle of elevation would be 84 degrees 30. That'd be 90 minus 5 degrees 30. So that would be an angle of elevation. But in this case, 95 degrees 30. Now, the other zenith angle is measured from that, and I can tell you that very easily with the zenith angles you can reduce these. The horizontal distance, say from A to B, is just equal to slope distance times the sine of the zenith angle. Now it happens to be sine, but it's very easy to work out which one it is, because if you can't remember whether it's sine or cosine, it's always the one that's like 0.999 or close, to 1, because usually our slopes are not that great. So in this case here, it's just 126.37 times sine 95 degrees 30. And you stick that into your calculator. Don't forget to convert the degrees in minutes to degrees in decimals, and do the sine thing, multiply it out, round it to 2 decimal places, 125.79. There you go. Now, just as a bit of an independent check on this one, and just as a point of interest, I've just done the horizontal distance there, and is equal to the slope distance times cos 5 degrees 30, which, believe me, comes out 125.79, despite the fact of my having left the 9 off in this case for some reason known only to me and the GCSB. Never mind. Here we go, just to check our other horizontal distance. So once we've reduced our 125.79, we put that in on the diagram in red, just over here. Then we move to our other horizontal distance here, 127.39 times sine 82.35. Of course, that's a angle of elevation, as it turns out, of about 7 degrees 25 minutes. Multiplying that out, 126.324, and rounding to 126.32. Alright, and so having got our triangle in place, we move on now to the final solution to our problem, that is, not to life itself or anything else. So draw up the triangle again. I've draw it up. I actually just copied it from the previous layer, but you can't tell that from here. And so we've got to solve this. Now, looking at this, we can see here that we've got two distances there, and we want to find the third. We've got the angle, two sides in the included angle, as it turns out. And although I've never told you this before, that's the classic sign that you need to call on the old cos rule. So two sides in the included angle, cos rule, cosine rule. Here it is. I've just put it in there and labelled up the triangle in lovely shades of magenta there. A squared equals b squared plus c squared minus 2bc cos a. Rolls off the tongue, really lovely that. So let's just put that in. And there we go, a squared, and we're putting in the various values, 126.32, 125.79, they're all squared, minus 2 times 126.32 times 125.79. Notice I haven't left off the 9 this time, and then that's multiplied by the cosine of 56.45. Now, of course, that's for a squared, what we've got there. We don't want a squared, we just want a, so just subtly there with the magenta just indicated that we're square rooting both sides. So a equals the square root of all those numbers and what have you there, 119.8665. Rounded that to a equals 119.87. So there you are, QED, quite easily done.